Hi, welcome back. Up next, we have Banu with driving the data pipelines for connected vehicles with Spring Cloud data flow. Take it away, Banu.
Thank you, Arvind. Hello, folks. Thank you for joining me this afternoon. Today, I'll be talking about an exciting topic that is basically the Spring Cloud data flow, right? A previous speaker alluded to it. So what I'm going to do is bring you a use case on how you would leverage the Spring Cloud data flow in a context of connected vehicles. And this is a very important aspect. The connected vehicles are becoming prevalent today. And so that's a very important concept, important instrument, if you will, for a vehicle. And so we'll be talking about the Spring Cloud data flow and how it applies to this particular scenario. So again, it's an open grade, production grade, open source implementation. Okay, so by that I mean we're using Spring, and Spring is production grade. Now, so what we'll be talking about today is on data pipelines, what it is. We'll just dive into what data pipeline means. What is a connected vehicle ecosystem? What is the problem statement that we are trying to solve here? What is the solution? And deep dive a little bit into the solution, and I will give you a demo of that particular solution to some extent, right? So I'm not going to go deep into the actual implementation, but I will give you a brief of how you would arrive at a particular problem. So what are data pipelines, right? So you have data on the left, you have data sources on the left, and the data sources on the right, and data targets on the right. And what you want to do is to transfer data from a source to target. And you would need some mechanism to transfer these pipelines, transfer these data, right? And what is that mechanism, right? So that mechanism is your data pipeline, or that's a conduit to getting your data from left to right. And there are different ways you can ingest this data, right? One is streaming, another one is CDC, another one is a batch process. Of course, the streaming is the most real-time. CDC depends upon whenever the data changes, you do that. Batch processing, of course, is asynchronous, right? So in the sense that you will have to, a batch takes its own time to execute. It can be triggered, can be scheduled. And interestingly, all of these is supported by Spring Cloud Data Flow, right? I hope if you're not aware. Another key aspect to this whole data pipeline concept is to be able to manage and monitor, right? How do you manage and monitor this pipeline? How do you manage and monitor the data that is going through the data pipeline to those targets? You use something called a tap. So very much like a network tap, you tap into a data pipeline, right? It's like an oil well of information, a network of data that is flowing through. All we need to do is tap. So what I will be showing you today is a demo of how you would execute the step, right? And transfer it into analytics, into edge databases or edge sources where you can do analytics on that edge data that's coming through. This is becoming more and more kind of prevalent in many of our clients, in the sense they want to be able to analyze data that is moving, that is streaming through, rather than waiting for the data to go get transformed into data lakes or data warehouses and then do your analytics with. So what we call this is edge analytics. And this is becoming a very interesting field. And so we would like to enable this through Spring Cloud Data Flow. And there are lots of reasons why you want to use Spring Cloud Data Flow versus any of the commercial products. And the word commercial comes in. Even the cloud products, right? Whether it is a Google Cloudflow or Dataflow or Amazon's Glue, you would be paying a lot if you're using a cloud provider versus and using their commercial products versus using Spring Cloud Data Flow, right? So that is the intent. It's an open source product, and that is production grade, and has been implemented. So let's take a moment and look at what is a connected vehicle, right? So everybody drives a car today, and everybody is connected to some electronics within the car, and those electronics, whether it's sensors, or whether that is your SOS calls, all of this are connected to a certain set of components that are in the cloud, right? They may be in a data center of an OEM, or they may be in a cloud in the sense that it is like residing in one of the hyperscalers, right? But there are two parts of it. One is the data sources, that's basically the car and the vehicle, and the services and platform around it, right? Now, this is continuing to grow, and as you can see, new cars are coming in, autonomous cars are coming in, and all of these are producing a lot of data. And all of these data needs to be streamed, processed, and analyzed in real time, right? The key is real-time analysis. Usually what we do is, okay, let me collect all the data and then do an analysis and come back with some kind of an inference or a suggestion, right? After doing an analysis, and it may take 2 to 3 months to get you an analysis, right? That is no more the way, right? So we're looking at real-time data coming in, and we want to do analysis on that real-time data. We need to be able to contact our OEMs. The driver needs to contact insurance, parking. He needs to understand where he can park the car, where he can charge gases, and all of this is happening real time. You need to understand the roads and all of this, right? So this is the ecosystem of a driver and a car, right, today. And all of these are connected today. And what we will dive deeper into is a specific use case that is very unique to the automotive landscape, if you will. And that is basically the first notice of loss. And what we will dive into is this particular use case. And this use case is becoming more prevalent and more adopted among all our OEMs, whether it is GM, Ford, Chrysler, Volkswagen, name it, and Tesla even, and everybody, right? So what they want to do is to be able to control this particular use case, a first notice of loss. Usually what happens is in Estivile, right? So 2-3 years ago, or 10 years ago, I would say 10 to 20 years ago, when you get into an accident, for example, right? So what would you do? You have to make a call to 911 or some kind of a crash system. You would have to call your insurer, and then you'll have to go contact Shoplicate. And if you're lucky, the police or somebody emergency will do the work for you. But yes, everything has to be, you will have to do the manual work of calling, establish a schedule, and establish a completion date, right? And the problem these OEMs were facing with this particular not having control over this was the fact they were losing opportunities, marketing opportunities, financial opportunities, to the tune of 140 million, approximately, per point, and then it's around 1 billion. They were losing it. So what the OEMs like Ford and GM and others are doing is basically trying to control this F&O process, make it more friendly, make it more cost efficient, make their customers more happier so that they can retain the customer even after the accident. And that is what drives the connected vehicles F&O process, right? So they want that. So what happens here? Now you would be able to see that when you buy a new vehicle, you'll get an app. You can connect using the app to the OEM, and when there is an accident. And I'm not saying that you will get into an accident, but God forbid you get into it, and you need to be able to contact GM, for example, or Ford, for example, and have them kind of work you through the way, like, for example, OnStar or Ford Pass, right? We need to be able to connect using those technologies, connect to the OEM directly, and they will guide you to the proper place. So what happens there is that you get the full experience that GM or someone will provide you, right? Full experience. Therefore, the OEMs will have the customer within their control, and that is what every OEM is trying to do. And this is $1 billion opportunity. And on the right, you see in this particular first notice of loss, there are certain kinds of data models and components that are in play, whether it's an OEM or a driver or sensors, the data in the cloud, predictive model, analytic models. And then you have the repair shops and service centers and insurers, all collaborating together to give you a better experience. Now, how can we implement this, right? So how can we implement? There are multiple ways. We can use commercial off-the-shelf software like MuleSoft, or you can go to the cloud providers and they'll give you a lot of data flows, but data flow engines, right? But the customer has to pay a lot to get this kind of thing accomplished. So in one of our customers, what we did is we were able to reduce the cost of licensing, reduce the cost of implementation, reduce the cost significantly of even developer resources, right? So we were able to provide them developers at a reasonable cost because this technology that we use, that Spring, is it's prevailing, and every Java developer mostly knows that, right? So it's easy that you can go to the market and get the Java developer who knows Spring. And that's why we chose Spring Cloud Data Flow. So just to go a little bit deeper into what this particular use case is and when we were talking to the customer, right? So what was his main concern, right? This was, basically it's all I want, right? I want to collect collision data and send it to concerned parties, whether it's insurance and whether it is repair shops and not repair shops or rental, right? I want to be able to collect collision data and send it to concerned parties. I want to create an event and data management system to collect events and send data associated with events to concerned parties. Well, it looks nice, so it's an event and data manager, so I can throw a lot of even systems in place, right? So that is something that that we also thought. I also want the solution to be scalable, reliable, and future-proof, and that's key, right? So what platform do you deploy the solution to? Another key is I do not want the solution to store any data. How would we achieve it, right? So the data is moving. We don't want to store it in any place. We want to be able to take it from point A to point B without storing data, right? We need to be able to do the transformation that's required, transfer the data to the destination without storage. And that's a big challenge right today, because there's a lot of data that is coming in. And if it's not processed in time, it will be in a limbo, right? So we need to be able to store it somewhere. So what is the solution that we proposed, right? If most of you have, if you had listened to Penske last spring, around the spring one, right? If you can go to the 2020 archives, you will see a solution very similar to this, right? You have Polar Apps, you have microservices, you have APIs, and you have streams, all using RabbitMQ. I'm using RabbitMQ because that is something that is deployable today on PCF for Tanzu application service. Right? You can use application service catalog, which is also called the Tanzu application services, which is also called the PCF, which was called the PCF. And then you would be able to control, manage, and scale the solution easily. And that is key, right? Use PCF, use Spring Cloud Data Flow on PCF, set microservices up. You have everything under this one umbrella that PCF or Tanzu application services provide, and you will have a scalable solution. And this was actually implemented in Penske, and we adopted that to some of our clients, right? And what they had noticed in Penske was that they were able to support, with this particular infrastructure, 2 billion events per day and 850 application instances with 50 streams ingesting 700 GB of data, right? That is neat. So the additions that we bought together at Siebel was the Azure Event Hub, which collects events from the cloud. We have the Azure API Gateway and API Connect for exposing APIs, and then orchestration of microservices. We evaluated others, right? We wanted to see if Spring Cloud Streams could work. We also evaluated whether Apache Kafka and Apache NiFi would work alone, but it did not meet the cloud native standards that we were looking for. That is basically deployment on the TAS and be able to scale with the environment that we had in place. That is TAS. Another key thing was we need to have people who are knowledgeable about it, and we found that Spring developers are more knowledgeable about Spring Batch and Spring Cloud Streams and Spring Cloud Data, and it's easy to get people who can execute the solution. Execution is also key here. Now again, another piece to this is portability, right? I can take this old bundle with the PCF or TAS and deploy it to any cloud, whether it's a data center on the right, Google Cloud, or Azure. And our client had both Azure, Google, and the data center. So this was something that we proposed. It is highly portable, all right? So it is not constrained to any kind of a Google, like for example, if you go to Google Data Flow, right? What you're constrained. And you have to, when you try to move it to AWS, you'll have to do AWS glue or something to that effect, right? Now you have to start thinking about building applications purely in Spring, right? Using Spring Streams. Then that is Spring Cloud Streams and Spring Cloud Framework, and that will be a pain, right? So another thing is visibility. That is also Spring Cloud Data Flow provides visibility into the pipeline. So I'll touch a little bit upon that and why the solution is fantastic. I feel it's fantastic. Let's deep dive into this solution, right? Collision event. So what it means, what does it mean? What is a collision event, right? A vehicle crash occurs. There are multiple components that are acting in conjunction to send data to the OEM or in this instance, it can be GM or any automotive supplier, or Chrysler, Chrysler, which is, or Mercedes-Benz or Volkswagen, or any company, right, including Ford. Now, these crash sensors send a first set of data. That is, when the vehicle crashes, you have a front sensor that sends data, sending the vehicle info. All we need is the VIN number and the date of crash and the time of crash, right? We need a timestamp. That gets sent to the event hub that isn't sitting in the cloud. Now, all of this, why did we choose a data center? Because there were a lot of interacting applications that were residing in the data center. Therefore, we want to make sure that we were not, our whole process was not expensive, right? Egress is expensive, right? In a cloud. If you had put it in the cloud and you have to transfer lots of data back to the data center, egress, we got to pay years costs. So why not have this in the data center? And the customer had VMware tons of application servers sitting on it, and then we had a deployed Spring Cloud Data Flow on it. So as you see in the first event, right? So you get an event from the event hub. You have an incident microservices that collects the event, sends it to an aggregator, and then there is a distribution microservice, basically, that gets exposed onto the API Connect that is sitting in the data center. And then you have insurance, rental, and collision centers, take this particular information through those APIs. The other thing is also very, very important to understand, right? So all this data about the photos, so when you, for example, when you use an app, a GM app or a Ford app, you will be, or a Volkswagen app, you will be able to take a crash photo, start a process of incident report, right? Using a mobile app. All the information that gets transferred to the store, but to a blob store in Azure. Of course, I'm not showing all these microservices in Azure just for simplicity's sake, right? All of those have APIs, that is in other systems that are working together sitting in Azure that is sending data. I'm not showing those. I'm more concentrating on what's happening in Spring Cloud Data Flow. Now, what happens if it's in a storage blob, right? And a blob store is, right, we need to be able to we need to be able to see the changes, right? Any change that happens to a database, we need to be able to capture as an event. And that is where we have CDC Debezium. Now I'll touch upon that, right, a little bit, which basically captures the change in data and then sends off the data to an aggregator and of course to a microservice and to an API Connect. While this is happening, we need to be able to tap into it and be able to graphically visualize what's happening, graphically visualize what data is going in. And that is where we have Grafana, the small dashboard, that taps using the analytics, and I'll show you how it's implemented, using the analytics tab to tap in the data that is coming through the data pipeline. And you can actually visualize this data pipeline through a Grafana dashboard, right? And that makes it kind of even more interesting. So these are the two streams that we implemented in our clients, right? And so let me go to the next slide. So now I will take you to the demo so that you understand what I was talking about in terms of the solution implementation. So what I'm going to do in the demo is talk about a little bit about the Spring Cloud data flow itself. And then so what you see here is the Spring Cloud data flow interface, right? So you have lots of streams here. You can create streams in this, right? I can go to a stream and I can create a stream. And what I would like to do is also show you some of the streams I've already created. One of this, as I talked about, Debezium to analytics. We have an analytics tab. And you can actually take a look at a lot of these applications or components that are already available to you. You don't have to go to a commercial product to get this. Spring Cloud data flow provides you this. You can also modify this to not get tied to a commercial product because those are all proprietary. It's very difficult to make a change. And we have seen people trying to move away from a commercial product. It takes a lot of money and effort to do that. So my advice to you is use Spring Cloud data flow, right? So this is some of the two sets of streams that are created. What I would like to do is just give you a more detail of the stream itself. And let me see. So this is what I had created. Okay, you see a dotted line, which is a tab, and you see the log that is basically the direct to the logs, right? And you see Debezium. So what I'm, and for this particular, to make it simple, right? I'm connecting Debezium CDC to a MySQL instance that is running on a Docker instance within my local laptop, just to show you how the CDC works. The other log, and there is a tab to the analytics. Okay, so you can see this particular stream is deployed. So what I would like to show you is, before I go a little bit deeper into this, what I'm going to do is actually run this, right? And also show you something that I felt was very, very, very kind of interesting, right? It's a dashboard. You can get this, the same implementation. I copied the same implementation from Spring, and there are samples out there. You can just leverage those samples. And you have Spring experts who have developed these samples, try them out. It's very interesting, and you can apply it. I'm not showing the actual implementation because that's proprietary, but I'm showing you a sample of the implementation, right? Here's another CDC dashboard. So let me do one thing. I have a database, that MySQL database is connected to a log, as you can see here. And it's also connected to, let me just go back. It's connected to a log. Any changes goes to a log, and any changes goes to analytics. Analytics here is nothing but CDC. So let me do one thing. I want to start the traffic, right, into the database so that we can start the Debezium work, and you can see the process happening. So I'm going to insert, do some activity with the database. I'll go to loop through. When I do that, you can see some activity happening. You can actually monitor this activity. And some of the ways you can do that is go to the application, see how the applications are monitoring. Let me see. You can also look at the streams. I can look at CDC log, for example, see how it is performing. Right? You can see some activity just started off. you can see that Debezium, that series of dashboard, right? You can see some activity happening here. You can see the operations are already based upon the previous my implementation. So you can see the activity here associated with this. And finally, so this is something that we would like to think we are running, we are topped out, but you can see some of these analytics when I triggered off, what do you say, database interactions, right? So this is something neat. You can try it out. There are lots of samples available. So what I would like to do is basically talk about the next steps, right? We at Wipro have some proficient engineers and experts who can help you out with any kind of migration from middleware to an open source implementation. So we can help you with a free discovery session, right? And we also have, here are the contacts, and we have also a global breakthrough partner of the year. So what I would like to leave you with is you can reach out to us if you want to hear more about implementation, which I just showed you. If you want to be able to implement this in your own ecosystem, reach out to us. And these are some of the email that you can reach out to. And finally, I would like to thank you for your time, for listening to me patiently in this afternoon time. And please reach out to us, and we'll be glad to help you. Thank you.
Hi. Thank you so much for a wonderful presentation. We love WePro. I feel like I see you guys everywhere, and you guys have awesome tools. Excellent presentation. To continue the talk, because I feel like you have so much more to say, please join the Q&A session. You can find that in the Slack channel to the right. You'll get a link to the Zoom session, so you can converse with Banu. Up next, another exciting partner, Redis, is going to be talking about Spring Data Redis 2.6, the new features, and the future roadmap of Spring Data. 5 minutes past the hour, you'll see Deshaun Carter and Brian Samboden. So take a short break, and we'll be right back.